Alright, so the last time we left it, we had finished coding our 6 tasks, but we haven't really checked our code well. So there are certainly some errors or things that don't work quite as well as they should that we can fix. So let's maybe first see if we're really picking all the citations from the text. So let's run our random number extraction here. Let's run it again on the Dirk Nowitzki URL, run it only on this particular page, and then we start with the full text. And how many have we extracted here? 3,204, and now we're going to do the same thing without the citations. So we store this as N2, no citations, and how many numbers do we have here? 2,959, so that is a difference of 245. Alright, so let's check that this actually matches the number of spans here with this class. So here we are back on the Dirk Nowitzki page, so let's check how many elements here with the span we have, and it's exactly 245. So that is correct. So the difference between the two extraction methods is exactly the citations that we wanted to exclude. However, if we look at the bottom of the page, there are also numbers that are citation numbers, so it's just the end node here. So, however, if we check this one, it turns out there's actually no number in the text. So you can see here that this is made by the marker. So we have this class here that stores the citation number, and then the marker which displays it, but it's actually not part of the HTML, so it's not extracted. So that's fine. We're not actually covering those. So the citations are fine. So let's have a look at a few other things. Right, so the next thing we want to test is whether our extraction function works if we have more pages. So let's again save this, and we want to start on the Dirk Nowitzki page again, and we want to run for 100 pages. So, and let's just keep full text here. Let's just see what happens. Alright, so it seems here we have no new articles on this extremely weird page. So the problem is that if we try to look at this page, place the Dirk Nowitzki here, this is actually not a proper page. Now there is a page that looks like this. Now the issue here is that this is a hyphen, and the hyphen has to be turned into a Unicode, and if we're using Perl, as we currently are, then this is not happening. So let me illustrate the problem here. So this weird string here is returned from our next article, is then passed on here to the last element of the Perl, and usually this should be decoded into Unicode, but Perl doesn't do that. So there are different ways around this problem. One is to use just to decode this before we assign it to segments, but we haven't really talked about this in class. So a different alternative here, or an alternative here, is to use just functionality that we already know. So instead of assigning the next article this way, we just remove the current article with pop from the segments list, and then here we just add by hand the next article, and once we've done that, the problem should be gone. Now this is not something that is likely to appear on all wikis, so maybe you're lucky, but if you have any articles that use Unicode specific characters that need to be decoded, then you will also run into this problem. Alright, so I'm going to rerun this now, and now this time it should be fine. Alright, you see this finished normally, so we have now a very large list of numbers here in N1, and this is what we're going to do next. So we're going to check whether the numbers that we're extracting are actually the kind of things that we want. So for example, here we get a 0. Now technically it's not really a big problem because it's not included in our extraction anyway, but the function was supposed to only take things that are proper numbers with numerical meaning. Now 0 might have a numerical meaning, but it's not really what we're looking for, so we want to exclude this. What else do we want to exclude? So let's scroll down a bit here until we find other things that are not quite what we want, but that weren't covered by the test string. So here we have, that's some things that are probably scores, so we should also exclude these type of things that have a double colon in the middle. What else? So we have this 0, 0. This is definitely something we want to exclude. Again, not really a big problem because it's not part of our extraction. But you see another 0 here. 0, 1 is also something we want to exclude. It's also must have some kind of different meaning, not numerical meaning. So we have 0, 3, same issue. 121, again the same thing. So not much else for the moment. Maybe we notice something else later. Alright, otherwise this looks mostly good. Here's 20,000, this is fine. This is the type of thing that we want. Looks all good to me at the moment. Alright, maybe just scroll to the very end here, see if there's anything in this stuff. So again, this looks all good. Now, okay, so let's just be happy with this and make changes to our extract number function. Alright, so let's see if we can make some fixes here. So let's first add some test values here that we want to see removed later. So this, for example, we don't want to see removed. This one on its own, yes. This one as well, same as this one, or this. Alright, so let's see what we get currently. So extract numbers of the test string. We should run this first. It's just a single word. Okay, test string. Alright, so we get still everything we want, then we get stuff that we don't want, and let's see what we can remove. So first, the easiest way here to remove the double colon is obviously to add the double colon here to the set of characters we want to remove. So let's just see that that works. Right, so you see these things are now gone. Right, so next maybe let's have a look at everything that is a 0 and then followed by more digits. So we could add an OR here, but that becomes not necessarily easier to read. So let's have an elif here. Elif, the pattern we have here is it starts with a 0 and then is followed by digits. Now you'll see this is actually not exactly doing what we want. So if I run this now, so you see a lot of stuff that we actually want to include is gone because all the numbers that include a 0 at any point somewhere are now removed. So let me just comment this out so you can see the difference. Yeah, see here this one is removed, this one is removed, these all were removed. So what's the problem? The problem is that search searches anywhere in the digit string here that's passed on, but we only want to exclude those that start this way. So then that means instead of search we should use match, because yet match only looks at the beginning of the string. Right, so if we try this, you see 2018, the 18 here, 30, 90, they are all still there. Now the problem is that all the stuff that we don't want is gone, but also our 0 point number is gone. Right? So 0.34 here. So how could we get this back? So we could again make this more complex so that dots and everything not part of this, but it might just be easier to get it to these numbers earlier. So if we have a match, again we start at the beginning here, right? So that starts with 0 dot and then followed by at least 1 digit, then we want to include this, right? So digit string, and then we want to append it to our results. So let's hope this was correct and we get our 0.3 back. Well, we do, but we also get a lot of other nonsense back because I didn't pay attention to the fact that the dot on its own stands for any character. I just mean a real dot though, so I need to put a backslash in front of it. So let's try this again. And now we have what we want. Right, so we included a few more things, so our extractor should be better than it was before. Maybe we need to revisit this later if we come across any other issues, but yeah, just because it works at the beginning doesn't mean it works on everything, and so you always need to check your output when you have more input. All right, so what else should we do? Well, there's one other thing that I think would be very nice here. So we wrote this very nice function at the beginning, return first article, and then we are basically reusing the code again by copying the full code, but it would be much nicer if we could just call this function. Now the problem that I mentioned earlier is that we request the page here inside that function, and if we also want other things like, for example, extracting the numbers or extracting the page title, then we would request twice, which we kind of want to avoid. So what we could do is, instead of saying that URL here must be a string, we just call this maybe URL or soup, and we don't specify the type that it has to be. So we can either pass on a URL or a soup. If we pass on a URL, that means that if this is an instance of a string, so if URL or soup is a string, in that case we're going to still request the page and turn it into a soup. Otherwise, it means that we're passing on the soup, we're just saying soup is equal to URL or soup, and that means that we can use the function just as we did before. So here we pass on the URL and it returns us the first article, but this also means that we can now, instead of replacing all redoing all this code here, replace these parts here with our function return first article. So we can still have next article is nothing, and then we assign next article now to return first article, and now we're passing on the soup that we already have. And yeah, we're passing on the article set as well. So visited articles, and this should also work. So let's try the non-random walk here, and you see we get exactly the same random walk as before. The only difference now is that we have much shorter code, right? And then the same thing is of course true for our non-random extraction. So here we already have a soup, so instead of running all this code here, we just replace it, with the call of the function here. Now that of course required that you were familiar, what have I done here? I broke the code a bit, so this can all go. And now this is what we're left with. Right, so makes it a bit shorter here. It doesn't run forever. Right, so this all works now. So this is always what you should do, right? So if you have a function that is very useful, make it so that you can reuse it. Now, not necessarily something I expected for the midterm, but it's a good thing to know. All right, so what else should we do now? What we should do and what we should have done from the beginning is to write a lot of comments into the code so that we know what we're doing. Now, I didn't do this because I would just increase the duration of the videos, but this is obviously not very good code because it's not commented code and therefore very difficult to read, right? So I should basically say what I'm doing here, but I'm not going to do this now in this video. It's just going to take too long. All right, so I think this is all now looking pretty good. I mean, it's still possible that we could still find some more issues, but coding-wise, this is already looking quite decent. And you know, if we come across any errors or problems, then we'll fix them as when we get them. But I can't think of anything right now from the top of my head, so I'll leave it at that.